All right, everybody, welcome back. I'd like to introduce you to Helge Maus, who operates a company called Pixel Train, a training service company. And he'll take us through how Houdini and C4D are the perfect companion set.
Thanks a lot. Yeah, hello. I have to confess I'm a little bit nervous because normally I don't have so many attendees in my trainings because I make mostly corporate trainings, and so I have 1, 2, 3 artists. So, okay, are you afraid of Entagma? No? Yeah, I was a little bit afraid. I think Manuel doesn't need anything. He only needs somewhere a wax console, and then he rewrites Houdini completely. Using the help is too much work for him. Rewrite it, yeah. A really stunning presentation. My presentation is a little bit different because I live as a trainer, mostly in the German-speaking countries. So on my Vimeo channel, you will find a whole bunch of, I think, around 600 tutorials, but most of them in German, which is really a problem for me because many people write me emails, please translate them all to English. Yeah, it's much work, so I will do my best to make more English Houdini tutorials. A little bit about my work. I started really early with 3D because as a child I wanted to make something with special effects. Visual effects was not the term at this time because, yeah, I was born in '72, so yeah, it was made in camera, everything, and I wanted to go to film, and I came from a little village, and yeah, my parents said, yeah, film is in America, you have to learn something which you can get here, and so I made a long way, and 2000 I switched to a company with the name Adobe. I don't know if you know this company, sells graphics software and things like that. And so I was hired as an industrial clown, they said to me. Go to trade shows and make funny stuff for the people so that they believe everything is easy. And so they buy the software. And so my approach is a little bit different from Manuel and Moritz because I have to tell you, Houdini is the most easiest software out there. So it's so easy. Don't be afraid. Yeah. I worked really long for Adobe, then I added 3D software. I'm a Maxon certified lead instructor. So I work with concepts from Maxon, but I'm not really religious in the sense of software. So I also use Maya, Houdini, everything which I can get my grip on. And that's really good in my job because most of my clients are post-houses, broadcast companies, agencies, and I have to find for them solutions. So they are also not really religious normally. They have a problem they want to solve, and they hire me that I bring the team to the point that they can solve their problem, and they have to earn money. And so comes the question, what products do I do? You see, this is a little portfolio of my software pool. It's changing all the time because software evolves, and you have to change your software portfolio sometime to make the job done. And so comes the question, why Houdini now? Are there any Cinema 4D users out there? Don't be afraid, I don't know you, so I, many Cinema 4D users. Why do you want to learn Houdini? That's a good question because procedural motion means that we want to do motion graphics, we want to work in advertising and so on. And why Houdini? Because Cinema 4D is such a strong product. Yes, it is. And I think every Cinema 4D users know. But I saw at my clients that they have a problem coming. You see, the shots they have to deliver are getting more and more complex. That's okay for a software like Maya, Cinema 4D, Houdini, and so on. But the problem is the way of working. If you start with the idea and you want to do now something with your software and you go into the process, you build something and the client wants to change or want, in most cases, add something to the system, you have to go back in many cases and redo all the stuff. I can compare this a little bit with tutorials I sometimes see. Most of the tutorials I see are like recipes. So you have to do every step in absolute disorder, otherwise you don't get the result at the end. And if you want to change something in this chain, you have to throw away everything which was after the change. And this is a problem in circumstances where you are in a project and it's iterating extremely fast. Yeah? Then you say, oh no, I can't change this anymore, that's it now. Yeah, and it produces costs. The next step is motion graphics and visual effects are more and more the same. They come closer together. In more and more visual effects shots, we need now simulations, and yeah, these lines are a little bit, yeah, vanishing. Yeah, so you use the same techniques in both worlds. And if I go to a typical, for example, cinema user, but the same is for Maya user or Max user or so, I see that they have a lot of plugins installed to make their jobs done. Yeah? They add, for example, a particle system, an external one, so that they are more flexible. Then they need, for example, something which is plasma, fire, smoke, something like that. And you find nice plugins out there and you add this to your system. Yeah, and then you need something else and you add. And the problem with these plugins is that you have to maintain them. If the software gets a new version, you normally ask, can I update or do I have to stay in this software because this plugin doesn't have a current version for this or this plugin doesn't have, and you have to think about your workflow all the time. For example, if you, from my perspective as a cinema user, for example, I go in and say, okay, I want to have a simulation like this combined with MoGraph, combined with hair. I have to think about in which order I have to build everything. Every system is great, but it's a capsule. And if I go into this capsule and I solve this, I cache this out, then I can stack something on top of it. But if you then see you have to switch the order, yeah, you have to start again. So you have many problems in your workflow if you have plugins, because every plugin for itself is good, but the problem is the connection between these. Yeah, and so these are the typical problems my clients as trainings clients have, and they asked for solutions. And some years ago, you saw in my trainings portfolio, I used to train also real flow, and I trained X particles and turbulence, I still do, but the problem was always our clients, our artists want to do great art, and their brain is limited, like my brain is limited. And they have now to learn for this job a real flow, and then they have to learn something else and something else, and you see, you get slow. And for this, I found some years ago Houdini, because Houdini, like Manuel and Moritz says, is not a 3D software. Yeah, it is. Sorry, it's now on tape. Houdini for me is more like an operating system for making computer graphics. You have a whole bunch of really nice tools. It's a full-fledged 3D software, but most cases, and you saw one, and I think you will see today with Simon and so other examples, they use Houdini as an operating system for making their arts. You have many contexts which are sometimes really strange, like you've seen Motion FX, yeah, the animating system of Houdini. It's first a little bit cryptic, but it's really, really, really powerful. Yeah, you can add MIDI stuff, for example, into Houdini, and you drive your animations live with your keyboard, for example. You can do such crazy things, which you can't do in another software like this, yeah? So it's an operating system. It's an all-rounder. it's procedural, scalable, and extendable. You have seen a really great presentation how you can extend your Houdini with wax. So that's the perspective. And there's another technology which is named Houdini Digital Asset. This is something which is extremely popular in games. So what that means is, if I go later into some of the practice examples, I built capsules. I built my own tools in Houdini, and these tools normally are used in the Houdini context. But SideFX had this clever idea that they said, okay, if I build a tool which can do all the things, I can export it as a Houdini encapsulated digital asset and place it in other softwares to do the magic there. So the same idea, you build something which you can reuse. And Maxon Cinema 4D, for example, has the integration of the Houdini digital asset, sometimes not really at the same point of time, like for example in Maya or Unreal or Unity, because it's made by Maxon themselves. But if you now, for example, you have a version 19, you are able to drive digital assets which are made with the Houdini 16. Like I said, not all functions are there, but you can build something. So in some agencies I work for, there's only one Houdini artist which built tools, and the other artists can still work in their beloved environment, work there, and you give them the tools they need for the job. So maybe this is also a job opportunity for you, that you can look into this and say, yeah, I'm really good in tool building. I built the stuff they need. Yeah. So this is Houdini. Now I have prepared for this here, for this presentation, 3 examples, because I'm not an artist. Yeah, you can really help me with artistic stuff. I'm a trainer, so I want to find the best way of teaching you how something works. And I've made 3 examples to show you a little bit about the approach we normally do in Houdini. This first one is extremely basic. This is a problem which I want to solve with you, and I want to show you some of the typical questions my trainings clients have. They ask me, how does Houdini work? How do I make geometry? How do I render? How do I make my first AUVs, for example? I want to have an object ID, where to get it? Yeah, I don't find it in Houdini. These are the typical questions in every training. In the first case, the people stumble around and say, I don't understand this software. This is the first project we will do. In the next project is a typical thing we normally do is trails, moving points around, making wireframe stuff and so on. There I want to show you a little bit about different approaches, how to do something. You can do everything in wax, like you've seen. Yeah, you can program everything by yourself, but there are some tools in Houdini which you can use from the shelf. It's okay, yeah. You don't have to tell your neighbors, so yeah. Really, Houdini cracks make everything in wax, but yeah, we can use some stuff. I will show you a little bit about how to make something that particles move without simulation. This is a misconception most of the starters in Houdini have. They think, okay, Houdini is such a big flashed simulation program, and they try to do everything in simulation. If you need particles, make simulation, make simulation. The problem with simulation is that in most cases we want to art direct something. So if you really want to tell the system, you have to do this and this, in simulations you can do it, but it's much more work. And sometimes the sub-context, so the modeling context for some people, is really capable of doing the job without simulating everything. Yeah, so we will look a little bit about this, and we make trails and our own solver. And the last one is an example where I want to show you how to work with data from external sources. For example, Cinema 4D or Maya or so, you bring data into the system. Here with the Lambic, you also can use FBX if you like. And then we want to make holograms. So the whole topic is about point generation systems. I will show you 3 different kind of ways of making points, yeah, for different approaches you maybe go, how to connect this up, and then we build our own assets for color and alpha generation and for point size generation so that you can get exactly what you want. These are my 3 examples. I've pre-captured all these tutorials. These are around 2.5 hours in German, and I will recapture them after this event in English. So I only can go through the networks, but be sure you can do all the tutorials if you like them step by step if you're at home. So that's it to this point. We start with our first project, the rasterizer. And for this, I have to switch the mic and I have to make place here. Okay, you know, making live demos is always really dangerous because, yeah, you can see if something goes wrong. But the nice thing is I have such a big support crowd sitting here. That's nice. Okay, this is the project we want to talk about. And I didn't came about this idea by myself. I was looking a little bit around and find a tutorial which was really popular on the Cinema 4D side. And they built something like that here. You remember this tutorial? You have organic shape, and this organic shape is then rebuilt with these triangles here, and then there's a little bit stuff onto it, and yeah. And this is the first job we want to do. We want to build something like that here. The interesting part here is how to make a difference to, for example, a program like Maya or Cinema 4D. We start here with a simple grid. So to make it a little bit faster, I deactivate here the environment light for a moment. Okay. So, and the interesting part here is I don't have to take the final geometry, which I need later in the project. I take something really, really simple here at the first step, and then I went in and used the sculpt node. Houdini has a procedural approach. That means everything you do, absolutely every step you do, is a node. And every of these nodes encapsulate everything you have done at this point, and you can go back and change it. And that's a really nice thing about adding later some stuff into the system. So if you have a grid here, you see it's fully parametric. You've made this grid. You can then go in here and sculpt it at this point to get a little bit more organic shape. And then you see there's an asset which I built, which is named rasterizer. So this rasterizer does all the things I want to do to make here from this something like that here. And for everything here, I have parameters. To build something like that, you build this little network here. And you have seen the networks of iXPonsor, and you saw they are immense. They are extremely big. And this is something I found from my trainees. If they think about, do I adapt Houdini into my workflow or not, they say it's so complicated. Houdini is so complicated, so many nodes, so complex. You have to code, and yeah, that's a problem, because then the people don't try to do something with it. I can tell you Houdini is extremely simple, because you do all these node trees step by step, and you add, while you're working, more and more of this stuff. Jeff has said in one of his last presentations I saw, the power of Houdini, or the knowledge of a Houdini user, is not how good you do, for example, know all the parameters of a tool. It's you grow in your knowledge of nodes. You first start with your first 10 nodes you normally use, and over the time you learn more and more nodes which are in the system hidden somewhere, and you add them to your daily portfolio. It's like learning a language. Yeah? First you have only some words, and then you add more and more to it. And that's exactly the approach you go in Houdini. So if you have your grid, you see I started with an extremely simple divide node at this point here. And to do this, I do it here at the side so that you can see it. So after the sculpt, I can cut this here. And if you add a node, little tip, hold down the shift key and enter. So you directly get a connection, you directly get the highlight here. You don't have to hook it up all the time by yourself. In the divide node here, you see the job of the divide node is dividing up here everything you had before. So if you divide this here, I think I'm stuck somewhere. Let's go back. Yeah, okay, now it's working. You can tell here what you want to achieve as a result. I see I want to have triangles. And after I have all these triangles here, I have solved my first step here I want to do with the image. The next step I want to do here in this image is that I want to have every primitive by itself. This is a mesh and it's connected, and you see this if you hold down the middle mouse key. You see you have 64 primitives, which are the polygons in Houdini, but you only have 45 points. So you want that every triangle is a separate mesh. And for this, you can use a facet node. And the facet node here normally does shading things and so on, but if you go here to unique points, you suddenly see that the Phong shading is breaking. But in reality, if you go here, you have now separate polygons. And these separate polygons are exactly the thing I'm after. So if I take, for example, a polygon like this here and move it out, you see every polygon is now separate to the facet node here. The next step we then have to do is every of these triangles has to be scaled inside. And to do this, we have some special nodes. If you have points, for example, there's the point node which works on the point level. You have the primitive nodes, which are the polygons for this. And if you take this node and look into this node, you can make all kinds of manipulations here on these primitives, on these polygons. And one of the manipulation is the transforming. And if you go here to the transform, does it zoom in? Yeah. Okay, great. You see, these are all transforms which are now on primitive base, but the interesting part is here the pivot. This is green. Green normally means in Houdini that this is keyed, or there's an expression going on. And if you click here, you see for every primitive, we calculate the middle of the primitive. So we have a pivot for every primitive here, and then you can go in here, go over the scale, and scale these down, and you see you get exactly the thing we are after. The rest is extremely simple. You go in, make a poly extrude, and the next step after poly extruding all the stuff here, we can do it here, distance a little bit into the negative room, we need backsides, then we want to have bevels, you use a poly bevel, for example, to do something like that. This is typical modeling approach like in every other software. But the interesting part, like I've said, is that every step here is still intact. You can still work with every of these steps here. And this brings me to the point where I go in here and collect all my informations I've done until this point, and this is this tree until, for example, this point here, yeah? And I say this is the first step of my asset I want to build. The next idea then is that I want to place spheres exactly in the middle of every of these polygons. How to get exactly the middle? Manuel will say, it's easy, it's only one code line in Wax and you can do this. Yeah, but at the first day in the training, you better don't do that. So you'll use your trainees. So how to do this? After the facet node, where we divided everything up, I can use another primitive node. And this primitive node here does a really funny job. it scales every primitive to 0. That means I've shrinked every polygon to a point. You see, these are the points here of every polygon. And the funny thing is, if I go here now and say, show me the primitives I had before, they lie exactly in the middle of every of these polygons. But every of these points are 3 points. And I want to get rid of these. And this is the job of the fuse node. Fuse is like point merge or something like that. You fuse together everything which is in a special distance here. And now you get only 128 points, which are exactly in the middle of every polygon. And then you can take a sphere and use a copy to points node to place these spheres exactly at the middle. And then in a procedural program like Houdini, you have to merge later your results together. Like I've said, everything is still procedural. You can change everything here. That means if you now go here to the facet, you go here to the divide and you want to change it, everything propagates through the network until you come to your last node you have here. Okay. I have some notes more here, but I don't talk about this in the moment. We'll come back to this. So we have now this rasterizer here, and yeah, then we go out here. The last point I have now to show you is how to go in here and render everything like that. You have a renderer built in the system, which is named Mantra, and Mantra is extremely capable. I think I've deactivated some node here. That's the danger of live demos. You see? Sculpt is gone, yeah. Where's the sculpt gone? Okay. We can make this later. If you want to render this, you can go to Mantra and you can render it out. But the cool thing I find here is you have a built-in render window which does exactly the job at the first step you do. I close my Houdini for a moment and I go back here, discard the changes. Any questions so far? Okay, it's too basic. Do you need something? No? Okay. Everything is fine? Okay. So if you go here now into the render window, you can start your renderer in different approaches. And the funny thing is, in the moment you do that, you get a first Mantra IPR node which renders everything. And the cool thing is, this window here is like a look development tool. You can work at the same time like it renders. And the question is, where do I get here now the materials? We have a new context in Houdini 16 /mat here, where you have now your shaders. And this here is a really nice context because you can take here, for example, a shader. You see, if you press the tab key, you have all kinds of shader building. But the nice thing for a beginner is search for a principled shader. This is a full-fledged shader you know from other programs. It's a PBR shader, so it works compatible to Substance. So if you use Substance Painter, for example, and so on, you can really use the textures here, and it really works. Yeah, so it's no rocket science behind this anymore, until the point you want to do the rocket science, which we come in a moment. How do we associate the materials? You can drag and drop it here. But the problem in our asset to this point is that we built this asset here, go in, and we have plates and we have these spheres, and I want to have different materials on it. And if I only go here to the last merge and I want to drag something, everything is a big polygon soup. Everything is together. And so one concept in Houdini, which is extremely powerful, is the concept of making groups. And you see here two group nodes, one for the spheres and one for the plates, and in these I use group names. Everything which comes down here is a plate, and so I named the group by myself plates material. And here everything which comes down here, the spheres, is a sphere material. And these groups is something I use for adding materials outside my asset. That means if I go here and press the middle mouse key, you see not only the polygon soup comes here, but I also get these two primitive groups. And this is good for tool building. Always think about what do you want to use later in your process. And the nice thing is, Houdini itself uses so much that you can go in here. For example, you take a bevel node. And you see maybe I want later to change the beveling material. And you see you have slots here for outputting groups all over the nodes of Houdini. So if you want to have a group for the bevel, for example, you can say every edge face wants to be here, or every corner face I want to have here. You click this here, and absolutely in the next moment, you have here new groups which you can use later for the materials. That's cool. You add your stuff. Like I've said in the beginning, yeah, you don't have to have the whole recipe in your head. You add later your stuff. Okay, the material is really easy. I go here to the materials, say on this group I want to use this material, on this group I want to use this material, and then I'm happy, and then I'm going to the output. The renderer itself lives in the out context, and here you can add as many renderers as you like. Every renderer encapsulates all the data you need for the rendering process, and normally you name them for a job. That means if you sometimes want to use render layers, for example, in other softwares, Maya or so, you make a layer. Here I really often tend to go in and say, okay, I make 3 renderers which do different kind of jobs for me, and I can host them there all the time. That's the reason why we can select here our renderers and our cameras. Yeah? You can play with every renderer, and every renderer does its own job. And Mantra itself is extremely powerful. You can render nearly everything with this, and it's extremely flexible. Sometimes in the first step it looks a little bit strange, I know, but it's really easy to understand. If you go here, for example, and say, I want to change the image, for example, this is the image pathway, I want to save it, I have EXR, and you see I get all the options for EXRs here with the file name. And yeah, you can decide here what you want to have in your rendering. And the most important part for most motion graphics designer or visual effects artist is I want to have AUVs or multipass outputs, or Houdini says these are image planes. There are some image planes prepared for you. You see here shading position, the depth, normals. You can use all your lights and so on. But in most cases, you want to have more control about this. And for this, you can go here in this area here. Normally, you don't find anything here. With a plus, you can add a new output, a new pass, if you like. And this pass is a VAX variable. Oh, yeah. What is a variable? A name. Yeah, you can say, I want to have a pass with the information which I decide I want to have. And normally you have to build these variables. But Houdini is really easy. If you want to use something which is really common, the side effects guys have added you all the different ideas which normally are used for outputs. You see here a whole bunch of ideas what you maybe want to output, for example, a curvature or something like that. So really complex stuff. But in your days as a Houdini artist, it comes to the point where you want to define something by yourself. And this is something which I have found in the first act a little bit complicated. And so I added something which I named a multimat. I want to have the plates and my spheres on different layers in my output. Not on different layers on one layer, but a different color, red, for example, and green, for example. And I named this, I want to have a multimat. You can name this like ever you want, but how to get this? In, for example, programs like Cinema 4D, you have to add a tag and say, I want to have it in channel 1, channel 2, and channel 3. In Houdini, there is no concept like this, but it's more flexible. I said I want to have a multimat, and if I go now here into my materials, these are my 2 materials, I say every object which has the plates material has to be also in the multimat, for example, in the red channel. And everything which is the spheres, I want to have later in a different channel. And for this, I have to add these variables to the shader. And I do this by opening up this shader. Normally, if you add a principal shader, like this shader here has a little lock sign, which means it's locked for you. If you go inside, you see only a note that this shader is locked and you don't have to think about this. Yeah? But now we want to think about this. We want to go inside of this shader. And to do that, you make a right mouse button click and say, I really know what I want to do. I want to edit this shader now. And then you see that this here is only an interface of a wax tree. And if I go in here, don't be afraid, I make a double click. In reality, this here is the shader. You see? It's a little wax script. If you want, you can study this a little bit. You find many complicated tutorials which use this. It's okay. But the easiest part is go to the right side. And on the right side, you see these here is the output of all this, collect of everything which goes out. And the only thing you have to do now is, if you want to have a variable, for example, multimat, you have to add this to the system. And because this is wax, we will look into this in a moment in another context, you can make a bind export for this. Bind export means I deliver something out. And you can name this. In our case, it's multimat, because this is the variable I want to have. Then you can decide which kind of data type it is. If you have a color, it's a vector. And then you can decide if you want to have a default value. And now comes the part. If this has to be the plates, and we want to have it in the red channel, I go here and set the first one to 1 and the other two to 0. One important step here, don't forget this, is this here only exports when the input, this one here, is connected. Because this is empty, it will never export in the moment. So don't forget to tell the system always. I want always to export this information. That's it. And then you can go up, and you see the difference between the shaders now. You have now this little shadow here, and the lock is open. So this is the indicator for you that this here was opened. And if you go into my plates here, always go to the right side. You see here bind export, and the same for this here. You see right side bind export. You can place it everywhere if you like to search. And if you now render this and you want to check this, here's a little menu hidden. If you click here, it opens, and there you see all your channels, and here's a multimat. You see? And this is exactly what you want. And this system is so extremely flexible. You can deliver every attribute, everything which you have in the tree before, out to a channel without re-rendering the stuff. So it's much more flexible than in other programs, but it looks in the first step a little bit different. Okay? One last tip for the After Effects users under us. If you export EXRs from Mantra, you have a little problem, not a problem. As a Nuke user, you know that in an EXR you can have a data window. And this data window normally crops all the information so that Nuke only has to calculate what's really pixel information and not the whole plate. But for After Effects, this is a problem because After Effects doesn't understand the system, and it feels sometimes a little bit weird. at this point. And if you want to add this to your system, if you want to make EXRs here, go to metadata. And here you see an option, set EXR data window. Normally you don't find this option. Yeah, it's not there. You get it if you tell the system, I need more. And this is typical Houdini. If you want to get more, you get more. You can go to this little cogwheel here and say, go to the parameters interface. And now you see, these are all the parameters in the moment here in this mantra node. And here are all the available data fields and so on. You go here to the rendery properties and you search for EXR. It's really easy. And then you see only a little part of the EXR options which are there are showed in the user interface. And here you find the data window. And if you select this, you can click here, add it to your data, to your parameters, and then that's it. You click accept, and then you can tick for After Effects. I want to use the data window. No, this is for Nuker. I don't want to use the data window. And then you remove it at this point. So this was the first file I wanted to show you. The second file is this Plexus effect. Okay. And here you see it's also a really easy tree. I know, thanks. I started with a simple platonic. So if you go here, this is a platonic shape. It's a primitive, nice. And then I wanted to show you some different approaches, how you can move stuff around. So I started with a simple scatter. Scatter is the most popular node for starters because you get points somewhere. And these points here, I want that they move around in space. How to move them? Like I've said, a point in Houdini is nothing else than a particle. It's a little bit different from other programs. A point with some more attributes is a particle, and you can use them vice versa. So these are particles at this point. And some people now put them into a DOP network, use a pop solver for particles, and then you have a particle simulation. You have a really simple node which can do something like that. Here, it's a spring node. A spring node is like an old particle system approach. And if you take a spring node and look into this, you see normally nothing happens if you press play. But here is a tab for forces, and here you have really rudimental particle things like wind, turbulence, and so on. And if you add a little bit of turbulence, you see now you get your first particle animation without having a particle system. And these are only points on a platonic. So you see it's extremely easy from the approach. Okay, another approach would be, this is the next scatter here, I built my own particle driver, my own particle solver. And this is an attribute WOP. You have seen the wranglers in the presentation of Manuel and Moritz. WAX is the language which is normally used. And if you want to write WAX, you normally take a wrangler. So you see for different kind of stuff, you have here wranglers and you can use a point wrangler. And this was the field where you add your code. But there's another way of working with WAX code without coding. And this is a little bit easier to come into the game. And this is named a WOP. And it's absolutely the same idea. But if you go into a WOP, you see there's a network going on. It's a little bit like in Sim 4D Expresso or ICE or something like that. In Softimage, you can make visual programming. The cool thing is, this here is really WAX. If you go in here and you want to learn how it works, you can view the WAX code of this. Here it is. Yeah, this is the WAX code I've generated by this graph. But the nice thing is you don't have to write it. Yeah? Okay, so if you go here, you see it's a really basic setup. You find On the left side is everything which comes in. On the right side is everything which goes out. The bind export is something you know now from our shader tree. Wax is the same language like in the shaders. So absolutely the same ideas here. You don't have to relearn something. You take the position of the points, add a little bit of a curl noise to it, and the points move. That they move, you need something which changed, which is the frame number. I have some multipliers here with parameters which come from outside, and you add these positions here. That's it. And so, if you build something like that and you use the parameters on the WOP node itself, you see here now, you have your parameters, and you don't have to dive in all the time. You have an asset which works like a black box, but you can change it all the time. And normally, if you start, you only have 1, 2 parameters outside, and the longer you work, the more parameters you suddenly say, I want to add this to the system. I want to add that to the system. And so I have a mover which does exactly the same job here, which moves my particles around. But this time, I have here turbulence, I have the noise type, I can change here the change amount. I don't want to change, I really want to change everything you see. Now I'm flexible for later animations. Yeah? I don't have to decide everything. The next step then is to make trails. There are different approaches, but this here is a really easy one for the Plexus. I want to connect adjacent pieces. So every point is connected with the next one inside of a search radius, and I get a wireframe. Mantra is able to render these wires directly. So you don't have to mesh them with a wire or so on. But if you want to do this, a little tip, there's an attribute with the name width. So if they are too big, you can change the width with this attribute and you can scale it. Here in this example, I really wired it, made the group for the materials and so on, and cached it at the end. Yeah? I hope I have 3 minutes left to show you how to make trails out of this. For trailing, there's a trail node. We use it sometime to make motion vectors, but it also can make trails. But in most cases, I use it, I make motion vectors with this. But okay, it really can trail. But it's much more fun to trail by yourself. And so you can use a solver. You saw it with Manuel a moment ago. And this solver does a funny thing. Here is the input you bring into the solver. And this input is the previous frame. And a solver is nothing else than, this is the old one, I add something to it, this is the new one. And this is the job of a solver. It always adds something to the state you had. And I add points. And after this solver here, I have a streak of points, which you can render, but I want to have a trail. And so I added a name to every of these particles which I bring in. I named it ID. And later, with the add node, I can say, make a polygon out of this, connect every point, but only the points which have the same ID. And the result of this is you have here these streaks. Okay. And then I added everything together, and that's it for this example. So I only have 2 minutes left. So like I've said, I have captured everything as 3 hours tutorial with every step and so on, also for the last presentation. Do you have any questions which you want to have, or, yeah? No question at all. That's okay. Then I hope it is useful. The purpose of this demo was to show you can use it, Houdini, like a visual effects artist or a wax artist, but the approach is really often much simpler, and you can add it more and more to your workflow. So don't be afraid of using Houdini, because it looks complicated at the first place, because artists normally show their best work. Yeah? And if you want to learn, then you have to have like a stair where you can start, and Houdini isn't complicated at all. Thanks.